Hello everyone. So today we're discussing about lines of force and its properties. So what are lines of force? So let us consider a north pole, unit north pole placed in a free space, free to move. Then when magnetic field is applied, the lines where it draws the path of the North Pole going from north to south or anywhere is called lines of force. Is called lines of force. These are also known as flux lines. So there are some properties based on the lines of force. Let's discuss them one by one. So first is lines of force never intersect each other. They never intersect each other, which means a lines of force, if A is a line of force and B is another line of force, then they will never intersect each other, because a line of force only can move in one direction, but when it crosses each other they are available two directions are available, which is not possible. If we draw a tangent to the line of force, then we can show the magnetic field direction of that pole. So this is our magnetic field direction and this is our flux lines or magnetic lines of force. Next comes number of lines of force per unit area shows us the density or the magnitude of magnetic field intensity. So more the magnetic lines of force, more is the magnetic field intensity or its magnitude. Next is magnetic lines of force always can be represented in two ways. One is uniform, another one is non-uniform. So this is our uniform one, this is our non-uniform one. Uniform lines are parallel to each other, but non-uniform lines of force are not parallel to each other. Then lines of force always tend to go from north to south pole. Always go from north to south. Tend to go. Next comes representation of lines of force. Next comes representation of lines of force. Line of force I have already showed you that they can be represented in two ways. One is uniform, another is non-uniform. This one is a non-uniform one, this one is a uniform magnetic lines of force. Then comes intensity of magnetic field. Intensity of magnetic field is equal to magnetic lines of force or magnetic flux by area. So magnetic lines of force and the area gives us the magnetic field intensity. Next comes current loop as magnetic dipole. So current loop as magnetic dipole is also shown like this. This is a current loop which has I current flowing in it, and it behaves as a magnetic dipole. This is also known as Amphiny's hypothesis. Then magnetic dipole moment of a revolving electron. A revolving electron also possesses magnetic lines of force and also behave as magnetic dipole. Okay guys, this much for today, and we have discussed today about magnetic lines of force and its properties. Thank you.